Very good morning, all. Am I audible? Please let me know. Am I audible? Okay. So I hope I'm audible. Let us start this session. So today we are in the last part of our fault analysis, stability and protection. So let us solve few more problems based on stability. In our last class, we saw how questions was taken from protection and how to crack those questions, how to apply the basic knowledge. And we have also seen plenty of questions in fault analysis. Now there are few more things about to cover in stability. Let us see all those things one by one in this lecture. Let me start the class. Okay. Let us take the first question. The question number one is the load carrying capability of a long AC transmission line is. There are four options given for that. One is always limited by conductor size. Second one is limited by stability consideration. Third one is reduced to low ambient temperature. And fourth one is decreased by the use of bundled conductor of single conductors. Anyone? What can be the correct answer for this question? The load carrying capability of a long AC transmission line is, first you must understand, whenever we are trying to transmit the power from any point to any point. Let us take point number one, point number two. When we are transmitting the power from one point to another point, what are all the things that we need to consider? First one is of course conductor size, and second one is we need to discuss about stability. Third one is we need to discuss about the temperature issues. Of course we must, and we know why we are going along with the bundled conductor, twisted conductor, composite, why we are using all aluminum with the steel reinforced. Why we are using all these conductors? What is the purpose? In order to reduce the losses, skin effect, corona loss, everything we know. But what is the major issue? When we are trying to transmit the AC power for a long distance from one point to another point, the problem along with the big problem along with the transmission line system is stability consideration. That is the major issue. If system is stable, then we can transmit economically by investing some extra money also. If there is no issues with our system, if there is no any problem in our transmission line, then what is the problem along with the system to transfer the power from one point to another point? நம்ம ஈஸியாக transmit பண்ணிடலாம். அப்போ ஒரு பவரை வந்து நம்ம லாங் டிஸ்டன்ஸ்க்கு டிரான்ஸ்மிட் பண்ணும்போது தி மேஜர் கன்சிடரேஷன் இஸ் ஃப்ரம் ஒன் பாயிண்ட் டு அனதர் பாயிண்ட். யூ மஸ்ட் டேக் கேர் அபவுட் தி ஸ்டெபிலிட்டி. சிஸ்டம்ல ஃபால்ட் வந்தால் எவ்வளோ கரண்ட் வந்து ஃப்ளோ ஆகும், பிரேக்கர்ஸ்க்கெல்லாம் எவ்வளோ ரேட்டிங்ஸ் வந்து நம்ம டிசைன் பண்ணணும், லைட்டிங் வோல்டேஜ் எவ்வளோ வரும், நம்ம எவ்வளோ வோல்டேஜ் வந்து டிரான்ஸ்மிட் பண்ணுறோம், ஸ்விட்சிங் ஓவர் வோல்டேஜோட எஃபெக்ட் எப்படி இருக்கும் டிரான்ஸ்மிஷன் லைனில், வாட் டைப் ஆஃப் ப்ரொடெக்ஷன்ஸ் நம்ம கொடுக்கணும். ஏன்னா பேஸ்ட் ஆன் தி அன்ஸ்டெபிலிட்டி சிஸ்டம்ல வந்து டிரான்சிஷன் ஸ்டெபிலிட்டி வரும் இல்லையா, சிஸ்டம் வந்து டிஸ்டர்ப் ஆகும்போது எந்த மாதிரியான ரிலேஸ் வந்து நம்ம யூஸ் பண்ணணும், வாட் டைப் ஆஃப் circuit breakers we have to give in the transmission line. So that things we must take care. So analysis of stability for a long transmission line, that is the too difficult task. So what is the finalized conclusion? Long transmission line எப்ப நம்ம பேசினாலும் the major consideration that you should keep it in your mind is stability consideration. Okay, so the correct answer is option B. Next one, the maximum power will be transferred from the sending end to receiving end by a transmission line when. This is condition. They are given many options. If you know the answer, you can drop it. Just to read the question once, one more time, and give me the answer. Just to try. You can try it by yourself. What is the condition? That is theoretical question. You might have observed all these things theoretically. Okay, sir. Let us see. Question என்ன கேட்டிருக்காங்க? Maximum power will be transferred from the sending end to receiving end by a transmission line when. First of all, what is the formula to obtain the power? We are using the standard formula is sending end voltage into receiving end voltage upon reactance X into sine delta. This power will going to be maximum. In the power நம்ம எப்படி maximum ஆக்கலாம் அப்படின்னா it will be maximum when the value of delta will become 90 degree because the value of sine delta equal to 1. That is the first condition. There will be one more condition. If you derive this expression, then you will get one more derivation. This power will be achieved maximum value when the value of reactance will become root 3 times of resistance. That is the second condition to achieve the maximum power. So there are two things. One is delta must be equal to 90 degrees. Second one is reactance offered by the transmission line. When it will become root 3 times of resistance, then also your power will become maximum. So these are the two conditions. Now go through the options and drop the answer. What they said, option A is the line reactance is root 3 times of the resistance, correct. Second, torque angle equal to 90, both are correct. So the correct answer is option C. Okay. Let's go ahead with the next question. What is the next question? If 800 kilovoltage transmission line is having per phase line inductance, how much it is? 1.1 millihenry per kilometer, and per phase line capacitance 11.68 nanofarad per kilometer. Ignoring the length of the line, its ideal power transfer capability in megawatt is dash. That is the question. Anyone? What will be the answer for this question? Power transfer capacity of the transmission line. According to the given data, first of all, what is the formula? That is surge impedance loading. What is the maximum loading capacity of the transmission line? The maximum surge impedance loading capacity of the transmission line can be calculated with the help of V square by Z. That is characteristic impedance or surge impedance offered by the transmission line. We all know when the transmission line is lossless, then the value of surge impedance or characteristic impedance can be simply written as L by C whole power 1 by 2. That's all. Now all data already clearly specified in the question itself. Now you can simply calculate. See, I have already written the formula for surge impedance loading per phase. If you are calculating it for single phase, then V phase square divided by characteristic impedance. If you are calculating it for 3 phase, then it will become 3 times of per phase. V phase square divided by characteristic impedance. Okay, sir. Since our transmission line is star connected, in case of star connected network, per phase voltage will be equal to line voltage divided by root 3. If you substitute that value here, then what will you obtain? If I derive this expression, it will become 3 times of line voltage divided by root 3 whole square upon characteristic impedance. Now root 3 whole square will become 3, so it will be 3 into line voltage square divided by 3, 3 getting cancelled divided by ZC. So what we have understood here, 3 times of per phase square divided by ZC equal to, directly we can say VL square divided by ZC. Both are same only. Are you getting, sir? Either you can write it in terms of line voltage for 3 phase. I am writing it for 3 phase. If I am writing it in terms of line voltage, then that factor 3 will be gone. If you are writing it in terms of per phase voltage, you can consider 3. Okay, don't think too much. Okay, let me substitute the value. Given it is 800 kilovoltage. Kilo means 10 power 3 whole square upon, what is the value of L? L is given as 1.1 millihenry, 10 power minus 3 per kilometer, divided by 11.68 into 10 power minus 9, that is nano, whole power 1 by 2. Now take your calci just to reduce this expression. So I am getting 2085 into 10 power 6 watts, or I can say 2085 megawatt. So what is the correct answer? Option C is the correct answer. Fine. Let us go ahead with the next question. What is the next question now? An 800 kilovoltage transmission line has a maximum power transfer capacity of P. If it is operated at 400 voltage kilovoltage with the series reactance unchanged, same reactance, then what about the maximum power transfer capacity is approximately? Then the maximum power transfer capacity is approximately equal to dash. What will be the answer? Anyone? Just try it and then tell me the answer. Drop your answer in the comment section. Anyone? Okay. Let me solve the question. First of all, we are talking about maximum power transfer capacity. Okay, sir. They clearly mentioned that 800 voltage transmission line. Let us start the derivation. We all know the power can be written as power P can be written as sending end voltage into receiving end voltage divided by reactance X into sine delta. But since they are talking about maximum power, so maximum power means it will be equal to only sending end voltage into receiving end voltage divided by reactance X. While achieving the maximum power, we all know delta will become 90 degree, reactance X will become root 3 times of resistance R. Just to remember these two, don't forget. Okay, sir. So sine delta, sine 90 will become 1. So power will become maximum, P max. If you observe, this power is depends on square times of voltage, sending end voltage, receiving end voltage. And they didn't differentiate sending end voltage receiving end voltage நடுவுல ஏதாச்சும் drop இருக்கா அந்த மாதிரி அவங்க எதுவுமே சொல்லல. So generally you have to observe what is the relation here. So maximum power is directly proportional to square times of voltage. There are two voltages. Yes, sir. That is the first conclusion according to the given data. And they told they are maintaining the value of reactance as constant. They only told remains unchanged. Okay, sir. அப்ப இதுல இருந்து நம்ம எப்படி எழுதலாம்? P max 2. Can I write like this? P max 2 upon P max 1 equal to V2 by V1 whole square. That's all from this derivation. From this what we can say, case number 2, P max 2 will become equal to P max 1 into what is the value of V2? V2 second time they are reducing the voltage 400 kilo voltage 10 power 3 divided by 800 kilo voltage whole power 2. They only told case number 1 it is 800, case number 2 it is 400. So 10 power 3 10 power 3 cancel, 20 cancel, it will be 2 times. So it will become what? P max 1 by 2 whole square, P max 1 divided by 4. So what is the conclusion? They have reduced the voltage. Initially they kept 800 kilo voltage and then that voltage will be reduced to 400 kilo voltage. Voltage will be reduced off, whereas power will be reduced 4 times, 1 by 4. So what is the conclusion? P max 2 will become P max 1 by 4, that is P by 4. So the correct answer is option D. That's all. Let us read the next question. Next what they told, if a 500 MVA 11 kilo voltage 3-phase generator at 50 Hz feeds through a transfer impedance of 0.605 ohm per phase and infrared bus also at 11 kilo voltage, then the also an infrared bus also at 11 kilo voltage, then the maximum steady state power transfer on the base of 500 MVA 11 kilo voltage is dash. What is the question actually? If you observe the question, given rating is 500 MVA 11 kilo voltage 3-phase generator, 50 Hz feeds through the transfer impedance, transmission line impedance, reactance value கொடுத்திருக்காங்க per phase ka. Infinite bus ல voltage எவ்வளவு இருக்குன்னா same 11 kilo voltage தான். Now the question is, அப்பனா maximum steady state power transfer, maximum எவ்வளவு power வந்து steady state ல transfer இருக்கும் அப்படிங்கறத question. Anyway, you all know the formula, but did you notice answer was given in per unit. Per unit la கொடுத்தா நீங்க எப்படி போடுவீங்க? Actual value divided by base value. First let us calculate the actual value, later we will decide the rest of things. Okay. Now base MEA they clearly given, that is 500. Base MEA was clearly given as 500. Just keep it. Next let us calculate the maximum power transfer capability. Just now we saw the formula. What is the formula? For generator, it is generated voltage into terminal voltage divided by reactance X. Okay, sir. Same formula. There is no changes. And condition also remains same. What is the condition? Delta equal to 90 degree, reactance X equal to root 3 times of R to achieve the maximum power. Okay, sir. Next thing, they clearly told voltage generated, rating of the generator also 11 kilo voltage, terminal voltage at the infinite bus, that is also 11 kilo voltage. And the reactance X they told that will be 0.605 per phase. Everything is clearly specified. So what we can do is we can easily identify the maximum power. Pmax equal to, once again you should think, sir, whether we need to consider the line voltage or per phase voltage. As I already told you, see, if we are considering it, if we are calculating the three phase power, anyway we are calculating three phase power. 3 times of what we must consider is per phase voltage, per phase induced EMF divided by per phase reactance. Everything under per phase. That is the first conclusion. And the next thing is, கொஷின்ல வந்து த்ரீ ஃபேஸை பத்தி பேசும்போது அவங்க எந்த டேட்டாவுமே கொடுக்கல, வெதர் இட் இஸ் ஸ்டார் கனெக்டட் ஆர் டெல்டா கனெக்டட் அந்த மாதிரி எதுவுமே கொடுக்கல அப்படின்னா பை டிஃபால்ட் யூ ஹவ் டு டேக் தட் இஸ் ஸ்டார் கனெக்ஷன் ஒன்லி. பை டிஃபால்ட் யூ ஹவ் டு டேக் ஸ்டார் கனெக்ஷன். மென்ஷன் பண்ணல அப்படின்னா ஓகே சார். அப்ப நம்ம கேஸ்ல என்ன பண்ணிக்கலாம், பர் ஃபேஸ் வோல்டேஜ் வேணும் அப்படின்னா 11/√3. Generator voltage also 11/√3. √3 into √3 will become 3. So finally what will you obtain? 3 into 11 into 11 divided by 3 whole divided by reactance per phase. Anyway, it is getting cancelled or not? Yes sir. So 11 into 11 divided by per phase reactance. Directly you can substitute the line voltages. So in 3 phase, if we are considering, when we are considering this factor 3, if you are having per phase voltages, then you can consider this factor 3. If you are having line voltages, directly you can substitute, that factor 3 will be cancelled. Okay sir. So the answer is what? 11 kilo voltage into 11 kilo voltage. Both are kilo. So kilo into kilo will become 10 power 6. This kilo will become 10 power 6 divided by 0.605. So what is the answer? If we reduce this, yes, we are getting 200 megawatt. That is the maximum power. But don't forget that is actual power. That is actual power. Okay sir. Now how to obtain the per unit power? If you want to obtain the per unit power, let me write here real power in per unit. For that you have to take actual power divided by MEA base. Similarly, if you want to calculate the reactive power also, actual reactive power divided by MEA base. That is how we are calculating. Yes sir. So from this, per unit value is, actual value is 200, base value is 500. So what is the answer? Actual divided by base is 500. Just to reduce this, 2020 getting cancelled, 2 by 5. It will be 0.4. So what is the correct answer? Option D is the correct answer. Am I right sir? Yes, we have completed. Let us take the next question. The steady state stability limit of a synchronous machine is connected to the infinite bus is 2.2 per unit. Steady state stability limit, that is called maximum power transfer ability of the transmission line. That is called steady state stability limit. Both are equal. That is 2.2 per unit. Infinite bus voltage is 1 per unit. Synchronous machine is having the voltage of 1.1 per unit. That is generator voltage. This is a terminal voltage. The transfer reactance between the generator and the infinite bus is dash. That is very small theoretical question. Sorry, one more question. Same formula. You can use it again. Just now we saw the steady state stability limit formula. That should be equal to maximum power transfer capacity of the transmission line. It will be equal to generated voltage into terminal voltage divided by reactance offered by the line. Now the question is, what is the value of reactance? From this what I can say is reactance X can be written as generator voltage into terminal voltage divided by maximum power. Generator voltage was given as 1.1, terminal voltage is given as 1 upon maximum power is given as 2.2. That's all. If we cancel it, it will become how much? It will be 1 by 2. That is the value of reactance. So the value of reactance will become 0.5 per unit. What is the correct answer? Option A. If you observe, option A is the correct answer. Okay sir. Let us go ahead to the next question. Next question is what? An alternator is having an induced EMF of 1.6, that is generator voltage, is connected to an infinite bus of 1 per unit terminal voltage. If the bus has the reactance of 0.6 per unit, reactance X is given, and the alternator also having certain reactance, that is 0.2, then what is the maximum power that can be transferred? Very simple question. Same question, nothing is changed. Same data again and again they had given. What is the formula? Maximum power transfer capacity equal to generator voltage into terminal voltage divided by total reactance. What is the total reactance? Total reactance will be the sum of reactance offered by the generator, reactance offered by the transmission line. Just a substitute, you will obtain the answer. Let me go ahead with the next question. A transmission line has the total series reactance of 0.2 per unit. Reactive power compensation is applied at the midpoint of the line and it is controlled such that midpoint voltage of the transmission line is always maintained as 0.98. If the voltage at the both ends of the line is maintained as 1, steady state power transfer limit of the transmission line will be dash. That is the question. Anyone? What can be the answer for this question? First, let me explain the given topology in terms of diagram such that you will understand the logic. Okay. What they had given is there is a transmission line. Okay. The transmission line is having certain amount of reactance. Now, they are doing some reactive power compensation such that this transmission line will be reconfigured as exactly at the midpoint of the transmission line. They are injecting the voltage controller here. So that is called a reactive power compensation. This reactive power compensator is maintaining the voltage at this node as 0.98 per unit. At the sending end, they are maintaining the voltage as 1 per unit. Receiving end also, they are maintaining the voltage as 1 per unit. Initially, they told this total reactance offered by the transmission line is 0.2. When we are breaking it exactly middle la வந்து நீங்க reactive power compensation பண்றீங்க அப்படின்னா இப்போ reactance என்னவா நீங்க break பண்ணணும் 0.1 0.1 இந்த total reactance 2 break பண்ணிட்டு midpointல நீங்க என்ன பண்ணலாம் you can provide reactive power compensation that is the given data. Okay sir. Now under this situation what is the question? Then what is the steady state power, that is maximum power transfer ability of the transmission line? இப்போ நீங்க என்ன பண்ணுவீங்க, let us start. அப்ப நம்ம இங்க இருந்து power transfer ability வந்து செக் பண்ணலாம். இங்க தான் power transfer ஆக போகுது, sending end power. How will you write down the formula? The sending end maximum power can be written as usual. The formula is we need to start from the sending end voltage into how much you can go from here. In between now we have one more midpoint. From here to here only we can check the ability. Into midpoint voltage we can write divided by reactance equal to sending end voltage is 1, midpoint we have 0.98 divided by reactance is 0.1. This one up to this point. So it will be 9.8 per unit. So that is the answer for the question. என்ன கேட்டிருக்காங்க, இந்த மாதிரி நீங்க ரியாக்டிவ் பவர் காம்பன்சேஷன் கொடுத்ததுக்கு அப்புறம் சென்டிங் எண்ட்ல இருந்து எவ்வளவு பவர் டிரான்ஸ்பர் ஆகுன்னு கேக்குறாங்க. ரியாக்டிவ் பவர் காம்பன்சேஷன் கொடுத்ததுக்கு அப்புறம் மிட் பாயிண்ட்ல வோல்டேஜ் வந்துருச்சு. அப்ப இங்க இருந்து இங்க தான் நம்ம ரியாக்டிவ் பவர் டிரான்ஸ்பர் எவ்வளவு இருக்குன்னு, ஐ மீன் ரியல் பவர் எவ்வளவு டிரான்ஸ்பர் ஆகுன்னு பார்க்க முடியும். அண்ட் தென் ஹியர் டு ஹியர் யூ கேன் அகைன் ரீசெக் தி பவர் டிரான்ஸ்மிஷன் கெபாசிட்டி ஆஃப் தி டிரான்ஸ்மிஷன் லைன். That's all. So the correct answer is 9.8 per unit. Option A is the correct answer. Okay. Let us go ahead with the next question. A generator, I think some portion is left here. Okay, generator is having, I think that is constant. A generator is having constant voltage of 1 per unit terminal voltage. Supplies power through the step-up transformer of 0.12 per unit reactance. Transformer is having 0.12 per unit reactance. Here the terminal voltage is 1.0 they told. And the double circuit transmission line to an infinite bus bar has shown in the figure. This is a double circuit transmission line. Infinite bus bar shown in the figure. The infinite bus voltage is maintained as 1 per unit. Infinite bus voltage on the 1 per unit correct maintain பண்றாங்க. Infinite bus voltage is maintained as 1 per unit. Neglecting the resistance and susceptance of the system, the steady state stability power limit of the system is 6.25, that is the maximum power transfer ability. It is given as 6.25 per unit. If one of the double circuit line is tripped, then the Resultant steady state stability power limit in per unit will be dash. Wow, that's beautiful question. First என்ன சொல்லிருக்காங்க கொஸ்டின்ல அப்படின்னா டயக்ராம கரெக்டா நம்ம அப்சர்வ் பண்ணிக்கலாம். We are starting from generator. ஜெனரேட்டர்ல இருந்து ஃபர்ஸ்ட் ஒரு இன்ஃபினிட் பஸ் வருதோ பஸ் 1. இங்க என்ன ஆகுதுன்னா வோல்டேஜ் வந்து 1 per unit கரெக்டா மெயின்டைன் பண்றோம். And then we are using transformer here. That transformer will offer certain amount of reactance. They clearly told that is 0.12 per unit. And then we are having the double circuit line. Since both are connected in parallel, so what I will do is I will keep two different reactants first. Then I will reduce it. See, this reactance is given as X. This is also given as X. Now tell me, from the generator, what is the total reactance? The total X equivalent will be 0.12 per unit plus X by 2. Am I right, sir? Since these two are connected in parallel, so the net reactance will become X by 2. Then from here, this one and this one both are connected in series. So this X by 2 and this 0.2 both are connected in series. That is the net reactance. Now case number 1, they told the maximum power transfer ability. What is the formula first of all? Sending end voltage into receiving end voltage divided by total reactance, X equivalent. This will be equal to 0.625. Yes, they told it this is 0.625. From this, what is the total reactance? This voltage is 1, this is also 1, it is already clearly specified in the question. So the X equivalent will be 1 divided by 0.625. I can write like this. This is the case number 1. Okay, sir. Now, from here, this X equivalent can be written as 0.12 plus X by 2. Now, we need to reduce this expression in order to obtain the resultant answer. Let me take Cal C and I will do it by myself. You can also solve it by yourself. Let me solve it by myself. So, what I am getting? 1 divided by 0.625 minus 0.12. So, I am getting into 2. The reactance X value I found, that is 2.96. So from the given data, I figure out the value of reactance. Next, what can we do? That is sufficient. இப்போ நம்ம ஈஸியா கொஸ்டினை சால்வ் பண்ணிடலாம். இந்த ரியாக்டன்ஸ் எக்ஸோட வேல்யூ அன்னோனா இருந்ததா, இப்போ அதோட வேல்யூ எவ்வளோனா 2.96 ஆமா. ரியாக்டன்ஸ் வேல்யூ 2.96. ஓகே சார். செகண்ட் கேஸ்ல என்ன பண்றாங்க அப்படின்னா, now the question is find out the maximum power transfer capability. So what we found is reactance X equal to 2.96. Just to remember, that is reactance X. இப்போ என்ன பண்றாங்கன்னா இதுல ஒரு லைனை ட்ரிப் பண்ணிட்டாங்க, ரிமூவ் பண்ணிட்டாங்க. ரிமூவ் பண்ணிட்டா we will have only one line. இதுக்கு முன்னாடி 2 lines இருந்ததால reactance வந்து X by 2 மாறுச்சு. இப்போ ஒரே ஒரு லைன் தான் இருக்கிறதால reactance என்னவா இருக்கும்? 2.96 அப்படியே தான் இருக்கும். Now what is the new power transmission ability? Now the new maximum power transfer ability of the transmission line will become once again sending end voltage into receiving end voltage divided by new reactance. Sending end voltage as usual 1, receiving end voltage as usual 1 divided by total reactance will become 0.12 plus 2.96. Directly we can write. So what is the answer of 2.96 plus 0.12? You have to take 1 minute. So I am getting here 1 minute guys. I think somewhere we made the mistake. I think I have done mistake at some point. I don't know where I have done the mistake. Reactance case we are getting what we obtain. Reactance case number 1, transmission line is 0.12 plus double circuit line, it is X by 2, right? So X by 2 plus 0.12, 1 into 1, they told it is 0.625. From this what we have done, X by 2 plus 0.12 equal to 1 divided by 0.625. So I think I made some mistake. You please correct it by yourself. No issues. I have done mistake somewhere. I'm correcting it. You please do it by yourself. Okay, guys, here on now only I have noticed. Sorry, power transfer ability is 6.25, right? I took 0.625. Sorry, that is the mistake. That is 6.25. Please correct it. So it will be 6.25. 6.25. So 1 divided by 6.25 minus 0.12 into 2. So I'm getting reactance x equal to 0.08 only. I made a mistake. Forgive me. So here we have to substitute 0.08. First case la enna பண்ணிட்டாங்க double circuit line, so net reactance will become x by 2. Now we are removing one line. அப்போ reactance ஒரு x அப்படியே தான் இருக்கும். இப்போ answer என்ன வரும்? First case it is x by 2, second case it is x only. So 0.08 plus 0.12 plus 0.12. If we take reciprocal, we are getting 5. So the answer is option D. Correct answer is option D. Forgive me, I have not noticed this value properly. Sir. Let us go ahead with the next question. அடுத்த question என்ன கேட்டிருக்காங்க பாருங்க. The question is the steady state stability limit. Okay. The steady state stability limit for round rotor and salient pole three-phase synchronous generator are attained at the values of the power angle delta equal to respectively. Steady state stability limit of a round rotor and salient pole. So they are talking about two machines, right? One is cylindrical. Round rotor means cylindrical. I hope you all know the answer for this question. Another one is salient pole machine. Okay. Now tell me, what is the answer for this question? This is theoretical question. Okay. Let me tell you the answer. Actually, in case of cylindrical machine, what is the formula to obtain the power? Power formula P is equal to, simply we can say, generator voltage into terminal voltage divided by armature reactance or direct axis reactance. We can simply say that is armature reactance into sine delta. So here what we can say is simply this power P will become P max when the value of delta will become 90 degree. That's all. That is for salient pole machine. Sorry, cylindrical machine or round rotor machine. So for round rotor, delta, when delta achieves 90 degree, automatically sine delta will become 1. That is the maximum value of sine delta. Power will become maximum. Okay, sir, that is over. When we are talking about another machine is there, na, salient pole. What is the formula? For salient pole, we have to write generator voltage into terminal voltage divided by XD reactance into what? Sine delta, plus we must consider one more power. What is that? V square divided by reactance X into, actually we have to consider 1 minute. V square divided by reactance X into 1 divided by direct axis reactance minus quadrature axis reactance into sine 2 delta. Correct? That is the formula to obtain the power for salient pole machine. So in salient pole machine, then what will be the answer? Now tell me, just observe the equation, and from this equation you can tell me the answer. What can be the answer now in this case? Power will become maximum when the value of delta will become 45 degree. That is, I can say we can achieve this power, we can achieve it will be maximum when the value of delta will become 45, because twice of 45 will become 90 degree. If you observe this case, for this it will become what? At a delta equal to 90 degree, we can achieve maximum power. All put together, if the value of delta lies in between 45 to 90 degree, this total power will become maximum. So what is the finalized conclusion here? So there are two type of power. This is what? This is power generated by the alternator, right? So this is what? Due to reactance we are developing the one more power. Saliency, that is salient pole power, that is saliency power. Okay, sir. Now what is the conclusion? The conclusion is, from this case we can say a salient pole machine will develop the power less than 90, greater than 45 degree. In between 45 to 90 it will develop the maximum power. Now read the options and tell me the answer. The correct answer is option D. The salient pole machine will deliver the power power will become maximum for round rotor at 90 degree. For saliency, it should be less than 90. Okay, sir. Now read the next question and tell me the answer. Next question is what? A salient pole synchronous generator is connected to the infrared bus will deliver the maximum power at an angle of. It is some, of course, the same question, right? But again, what? Salient pole. They are talking about salient pole synchronous generator which is connected to the infrared bus will deliver the maximum power at an angle of dash. What will be the answer? I think they made some mistakes in the options, right? See, option C and option D both are 45 degree. Yes, they had given, they had done some mistakes. What can we do? Okay, they are not given the condition properly. Anyway, we know the answer. It is less than 90 degree, greater than 45 degree. Almost we can say at critical condition. Anyway, option la வந்து இந்த மாதிரி conditions கொடுக்கல அப்படின்னா you can keep option C and D are wrong. You can remove that. Critical condition, let me write that approximately del will become equal to 90 degree. That is critical condition. Almost the system will become marginally stable here. இதை தாண்டி போனீங்க அப்படின்னா system will be unstable. So at a critical condition, we can somehow achieve the maximum power at delta equal to 90 degree. Anyway, in this question, they have not given any other options. We cannot directly choose delta equal to 45 degree. Option D is, I don't know, that is there is some mistake. This is wrong. So approximately, it should be less than 90, but I am choosing critical condition because there is no other options in the question. Okay. Take the next one. Two identical synchronous machines, A and B, running at the same speed. There are two machines, right? A and B, and are linked to the reactance X shown in the figure. Machine A will supply the active and reactive power to the machine B when delta is dash. When delta and voltage, they are talking about both of these things. Anyway, let me explain the concept. We know real power flow and reactive power flow. Real power will flow from low value of delta to real power will flow from high value of delta to low value of delta. Similarly, reactive power will flow from high value of voltage to low value of voltage. Correct, sir? Since they told reactive power is going from A to B, it means what? VA must be greater than VB, then only reactive power will flow from here to here. Since they told real power also going from A to B, it means delta A must be greater than delta B. And since they told the value of delta B is 0 degree, they clearly mention in the question delta B is 0 degree. So delta A must be greater than delta B greater than 0 degree. It means it should be positive. So what is the conclusion? Delta should be positive and VA must be greater than VB such that real and reactive power will flow from A to B. That's all. So what is the correct answer of? The correct answer is option D. Yes, the correct answer is option D. Okay, let us go ahead with the next question. A round rotor generator with the internal voltage of E1 equal to 2 per unit and reactance X equal to 1.1 per unit. Okay, sir. Is connected to a round rotor synchronous motor with the internal voltage 1.3 per unit and reactance 1.2. The reactance of the line connecting between the generator and motor is 0.5. When the generator supplies 0.5 per unit power, then the rotor angle difference between the machines will be dash. Very beautiful question. Let me figure out this story. Actually, they are considering a generator here. This generator will have certain internal reactance. Then we are considering one more transmission line in order to connect this generator with the synchronous motor. This is the reactance offered by the synchronous motor. So this is motor and this is generator. And they told this generator is generating the voltage of 2 per unit voltage, and this one is having the voltage of 1.3 per unit. This is motor induced EMF, back EMF we can say. This is generator voltage. Next, reactance offered by the generator is 1.1 per unit, and the reactance offered by the generator motor 2 is 1.2 per unit. Reactance offered by the transmission line is 0.5 per unit. Finally, next what they told is the power that is being transferred from here to here, the power transferred from power flow. They had given the power flow from here to here. That power value P, they clearly told 0.5 per unit. Everything they told. Finally, we all know real power will flow from high value of delta to low value of delta. High value of delta to low value of delta. This one may have certain value of delta, that is delta 2. This one may have certain value of delta 1. Now, how will you write down the power flow actually equation? Power flow can be written as, the power formula can be written as the induced voltage into transmitted voltage to the receiving end. What is the transmitted voltage now? That is back EMF. Divided by total reactance offered by this line into sine of phase angle difference between, that is high value minus low value. That is how we are generally writing the power flow equation. Now the question is, what is the value of this high value minus low? This difference is how much? That is the question. All the data is already given in your question. Just to substitute and reduce, you will get the answer. Okay, let us see. This power value is given as 0.5. This generator voltage is given as 2. This back EMF voltage is given as 1.3. Total reactance is how much? 1.1 plus 0.5 plus 1.2. So it is 2.8. So the total value is going to be 2.8. That's all. The one and only unknown is delta high minus delta low. Reduce 0.5 equal to 2 into 1.3 divided by 2.8 into sine delta. I am generally defining this total value, I am calling it as delta. That is high minus low. அதனால நம்ம ஜெனரலா டெல்டா டிஃபைன் பண்ணிருப்போம். நம்ம ஈக்குவேஷன்ல நம்ம டைரக்டா என்ன போடுவோம்? sin delta தான் போடுவோம். Actually the delta is the difference between the two values, delta 1 minus delta 2. That is high value minus low value, or we can say. Okay, fine sir. Now you can reduce it easily, you will get the answer. What will you obtain? Let me reduce it. 0.5 into 2.8. Sorry. 0.5 into 2.8 divided by so I'm getting 32.578 degree. So approximately option C is the correct answer. From this, what I'm getting is the value of delta high minus delta low. I'm getting 32.5789. Approximately it will be 32.58 degree. So the correct answer is option C. Option C is the correct answer. Sorry guys. Option C is the correct answer. Okay. Now let us go ahead with the next question. What is the given data? If a generator of 250 MVA rating has an inertia constant of 6 megajoule per MVA, its inertia constant on 100 MVA is dash. That is the next question. I hope you can solve this question. You don't need to expect the answer from my side. Solve the question and drop your answer in the comment section. Do it fast. You can do it. That's not a big question. That is very small question. What is the answer? Anyone? Drop it in the comment section. No one? Okay. So let me write the relation first. What they given? Given it is MEA rating. First they told S1, case number 1, given it is 250 MVA. Okay, fine sir. Next, second what they told, with this inertia constant is given. What is the inertia given? H1 equal to 6 megajoule per MVA. Okay sir. Second case, again they are given MVA2. They have given MVA2 100 MVA. Then what is the value of H2? That is the question mark. Since we all know the kinetic energy formula KE can be written as, it is the product of MV rating S into inertia constant H. That is, some people at some times instead of using S we will use G, generated power, MV rating. That is the kinetic energy formula. That is one formula. We know there is one more formula also. Anyway, here I am using this. Since they are not talking about the kinetic energy, so I am assuming that the kinetic energy remains constant. In both of these cases, the kinetic energy remains constant because we are varying the value of S and H in both of these cases. So remains, it will be constant. So from this what I can say, case number 2 it can be written as S2 into H2. Case number 1 it can be written as S1 into H1. So from this the new value of H2, inertia constant H2 can be written as S1 into H1 upon S2. Since the value of S1 is 250 MVA into the value of H is 6 megajoule for MVA divided by S2 is 100 MVA. Yes or no? If you reduce this, how much you will get? You can directly cancel it. It will become 2.5. 6 times of 2.5 will become 15 megajoules per MVA. So what is the correct answer for H2? 15 megajoules per MVA. Option A is the correct answer. Sure. Let us read the next question. Sorry guys. Okay. Fine. The next question is, the inertia constant H equal to 8 megajoules per MVA for 50 MVA generator. Then what is the stored energy? Just now I taught you what is the formula to obtain the kinetic energy. Stored energy means kinetic energy. Kinetic energy equal to what? It is the product of G into H. What is the value of H? What is the value of G? G is 50. It is 8. 8 times of 5 is 40. So it will be 400 megajoule. 400 megajoule. That is the answer. Kinetic energy. So the correct answer is option C. Okay. Let us read the next question. In 90 MVA, 11 kilovoltage water wheel generator has an inertia constant of H equal to 3. The stored energy in the rotor at the synchronous speed is dash. Once again, same. Once again, you are requested to calculate the value of H only. What is the kinetic energy? The formula to obtain the kinetic energy is G into H. One second. So it is G into H. What is the value of G? It is already clearly specified in the question. It is 90. Inertia constant 3. So it will be 270. But given in megajoule. So given it is in megajoule. So the correct answer is 270 megajoule. Next question. I think small questions all are right. Okay. 50 MVA 11 kilovoltage 3-phase generator has a stored energy of 400 megajoules. What is the inertia constant? I hope you can solve this. Kinetic energy equal to G into H. Question is H is what? So kinetic energy divided by G. Substitute, you will get the answer. Next question. 800 megajoules stored energy in the rotor at a synchronous speed. What is the inertia constant H for 50 Hz? 4-pole turbo generator rated at 100 MVA 11 kilovoltage. What all the data is given? Kinetic energy is given, MVA rating is given, and rated voltage, everything is given. The question is inertia constant H equal to what? Same question now. Kinetic energy is what? 800. MVA rating is given 100. 800 by 100 will become 8 megajoules per MVA. Direct question. Theoretical questions. Alright. So let us go ahead with the next question. Next what? The per unit parameters for a 500 MVA machine on its own basis, M equal to 20, X equal to 2. The per unit value of the inertia constant, inertia M, under reactants X on 100 MeA base. First, at 500 MeA base, value is given. At 100 MeA base, what are all the new values that we are going to obtain? That is the question. Now, how will you calculate the new per unit value? Anyway, let us calculate one by one. First, how will you calculate the MEA new? Sorry, M new, that is inertia. As we saw already, inertia constant and MEA rating both are inversely proportional. Just now I have written the relation. For H also it is a relation. Relation is inversely proportional only. What we saw, G into H is equal to kinetic energy. When kinetic energy will become constant, so from this we can say G and H both are reciprocal. That is inertia constant. From this what I can say, inertia also will become what? Reciprocal to each other only. So what is the conclusion here? Since these two people are also inversely proportional to each other, first conclusion, it means what I can say, M1 into G1, case number 1, equal to M2 into G2. So now the question is, M2 is what? New M2 for new base. So it can be written as old cases divided by G2. What they told, M1 was given as 20, G1 was given as 500 MVA divided by G2 was given as 100 MVA. If I will cancel it, what I will get? 20 times of 5 will become 100. So the new value will become 100 per unit. That is the new value of M. Okay, sir. That is per unit value actually. I would like to conclude one more thing. In per unit, it is inversely proportional. Right? Fine, sir. Just to remember this relation, because many of you may not know this one. And one more thing, அந்த derivation நான் ஒரு சொன்னல, just நீங்க ஞாபகம் வச்சுக்கணும் அப்படின்றதுக்காக சொன்னது. You no need to think, sir, how that relation will come here. H and இடத்துல எப்படி நீங்க M கொண்டு வந்தீங்க. Don't think like that. This is inertia constant only. I am not bringing any relation here. When we are doing the per unit calculation for G and M also, in per unit you will obtain the same kind of derivation. This is not per unit. ஜென்ரலாவே எப்படி இருக்கும் அப்படின்னா G and H reciprocal தான். But in per unit calculation, G and M also will become reciprocal. Okay, in per unit calculation. Okay, that's why I had to, in order to remember this, I had given this one. Don't bring the relation between these two parameters. Okay, fine, sir. Now coming back, one thing is over. In per unit, we understood that is the relation and we got the answer, that is 100 per unit. Next, we also know how to calculate the reactance. How will you calculate the reactance? Same relation. One minute, guys. Okay. When we are calculating reactance X, what is the relation between X and MEA rating, MEA base? So we know X per unit new. I can say X2 per unit new value equal to X1 per unit old into MEA new. That is formula. Per unit calculation of power system. That things you know, I hope. Now substitute the value. New value is 100. Old value is 500 into old value of reactance is given as 2. 0 is getting cancelled. 2 by 5 equal to 0.4. So what is the correct answer? 100 comma 0.4. Option D is the correct answer. Okay, sir. Read the next question and drop your answer. 500 MVA, 21 kilo voltage, 50 Hz 3 phase 2 pole synchronous generator having the rated power factor of 0.9 has the moment of inertia 27.5 into 10 power 3 kilogram per meter square, then the inertia constant H will be dash. That is the next question. How will you calculate? Let us see. According to the given data, we will proceed. Whatever the formula that we know, we will apply all those things. First of all, what they have given is moment of inertia is given. Right? Where is the question? Yes. Moment of inertia is given as 27.5 into 10 power 3 kilogram meter square. First, moment of inertia is given. From this, how will you calculate the level of inertia constant H? We know Kinetic energy can be defined as MA rating into inertia constant H. From this I can say inertia constant H can be calculated with the help of kinetic energy divided by G. Now please tell me, is there any alternative formula to obtain the kinetic energy? What is the formula to obtain the kinetic energy? How will you obtain the kinetic energy? Kinetic energy can be obtained in terms of moment of inertia. It can be written as m into omega, that is angular speed, divided by g. Can I write like this? Yes, sir. So let us write. I am just substituting. கொடுத்திருக்க data வச்சு நான் எழுதுறேன். அப்போ ஒமேகாவை நம்ம எப்படி எழுதுறோம்? Angular speed can be written as, since it is synchronous machine, I can write it as 2 pi n by 60. Yes, sir. Right. I think that is of m omega square, right? Yes. Here you will get omega square. I hope I am correct. Yes, I am correct only. I am cross checking. Fine, sir. Divided by g. Now, let us substitute all the values into g, that is base MEA. It is MEA is given or not? No, in our case, g is given as, see, g means rating should be in MEA. Question என்ன கொடுத்திருக்காங்க 500 megawatt தான் கொடுத்திருக்காங்க, but power factor is given as 0.9. We know real power can be written as MEA rating into cos pi. From this, g can be written as 500 divided by 0.9. So we can substitute that value here. So this will become 500 divided by 0.9. Next, this value is already given as 27.5 into 10 power 3. That is also given. Yes, sir. Next, so the value of this one also given 27.5 into 10 power 3. We can substitute. Then what about the value of n? How will you calculate the value of n? We all know n is nothing but synchronous speed of the synchronous machine. That can be written as 120f divided by p. So 120 into frequency is given as 50 Hz, 2-pole machine. So we can cancel it 6. It will become 3000 RPM, revolution per minute. So here you can substitute 3000. Now all the data are known. Just reduce the expression, you will obtain the answer. That is your task. Okay, I had given the idea. Let us go with the next question. Two identical synchronous machines having same inertia constant connected in parallel and swinging together. The effective inertia constant is m megajoules per MVA. Then each machine has the inertia constant of dash. It's very beautiful question, and of course it is very simple question also. Let me teach you how to calculate the inertia constant. Sorry, that is moment of inertia. Inertia constant when machine is swinging together, when machine is not swinging together. If the machine is swinging together, let us take, listen, there are two alternators. Let us take, there are two alternators. This is alternator 1, this is alternator 2, generator 1, generator 2. Both are having inertia constant h1 and h2. Suppose if they are swinging together, if they are vibrating in the same direction, then the net H equivalent will become, it will be the addition of h1 plus h2. Okay, sir. Suppose if they are not swinging together, then you must go with the parallel combination. If they are not swinging together, if they are not swinging together, in this case you can directly obtain, even moment of inertia also will become what? You can directly add them. If they are not swinging together, then you must go along with the parallel. Parallel operation means how will you do? 1 by m1 plus 1 by m2 in order to obtain the total moment of inertia. Similarly for inertia also, inertia constant also. Okay, sir. Anyway, in our question, machine is swinging together. When the machine is swinging together, how will you solve this question? H is equal to h1 plus h2. Since they told both machines are having same rating, total value is equal to 4. 4 is equal to h1 plus h2. But they told both are what? Identical. Identical machine means h1 equal to h2. So I can say 2h equal to 4. So for a single machine, it will become 2 megajoule for MVA. So the correct answer is what? Option A. Yes, this is one of the most beautiful question. A 100 MVA 50 heads turbo generator operates at a no load at 3000 RPM at a load of 25 megawatt. A load of 25 megawatt is suddenly applied to the machine and the steam valve to the turbine commences to open after zero point 0.6 seconds due to the governor time lag. Assuming the inertia constant is 5 kilowatt per kVA of the generator rating, the frequency to which generator voltage drops before the steam flow commands to meet the new load is dash. That is one of the most beautiful question. And second thing what I would like to conclude is this is the easiest question. Just you have to bring the relation between kinetic energy old and kinetic energy new and frequency. That is the only thing that you have to do. Anyway, I will give clue, but I am asking you to try it by yourself. Kinetic energy, we all know that is directly proportional to square times of speed of the machine. Since we are in synchronous machine, that is synchronous speed. Ns can be written as 120 times of F divided by P. Since pole of the machine is always constant, so I can say Ns is directly proportional to F. So from this directly I can say kinetic energy of the machine is directly proportional to F square. Correct, no? So from this what I can say is easily we can write because I had given the conclusion. Total frequency F2 divided by F1 can be written as kinetic energy F2 divided by F1 whole square can be written as KE2 divided by KE1. From this I can say whenever they are asking new frequency, that is F2 equal to F1 into KE2 divided by KE1 whole power 1 by 2. Okay, just to remember that is the clue for the above question. Try it by yourself. Spend your time because we have solved plenty of questions, right? And I had given everything. The only thing is how to collect this data. Substitute it here, you will get the answer. Okay. I have been, yes, if you want to wait, I will solve and tell me the answer. I'll tell you the answer. Give me 1 minute. First it will be 500. So I'm getting approximately my answer is equal to 49.24 heads I'm getting. Is it in the option right? Yes. I'm getting option C. You can cross check it and drop your answer. Okay. I hope you all have understood all the questions whatever that we have solved so far. So kindly go through the stability one more time and learn how to calculate the critical clearing angle and how to solve critical clearing time and all. There are few more questions, few more models. I will try to solve those questions in the next lecture. And of course, the next lecture is the last lecture in power system because almost we have been covered all the topics. There is one more topic yet to cover, that is load flow analysis. There are few more things to cover. There are few questions are there in load flow analysis based on the concept. We will cover that things in the next lecture. With this, we will complete the power system. Right? So if you are finding any new things, I am repeating. Kindly make the notes. Whenever you are solving the questions with me, should try to pause the video, collect the data, try it by yourself. After that, compare your solution with my solution. Right? Rest of things we will see in the next class. Thank you all.